Alright guys, welcome back to lesson 8. This is a new section where we are going to discuss a new concept called the lift force. Now that we have finished the drag force, okay, it's time to explain a new section called the lift force. A very important section. This is the force that acts opposite to the direction of weight. This is the force that helps airplanes fly, okay, that actually lift bodies opposite to the direction of weight. Now, before actually giving you formulas and getting into equations, let's watch together a short video in order to demonstrate where the lift force comes from and what it does. So let's see this video together. Okay, so in here you have a guy who has his hand outside of a window of a car's window, and the car is moving forward. Okay, and you see that initially the guy's hand is horizontal, okay, and as the car moves, look what happens. The guy starts to, simply change the angle of his hand. Okay, he's not actually exerting any force to lift his hand. Okay, his hand is automatically lifted. He is just changing the angle of his hand. Okay, and you can experiment this by changing the angle. What's gonna lift your hand is the wind. Okay, so you yourself are not exerting any force on your hand to actually lift it up. So how does changing this angle creates a lift force? Okay, and this is the main, or this is the basic principle of this section, is to demonstrate where the lift force comes from. So in here I'm gonna explain right here. Okay, I'm gonna explain right here. So what we have in here is we have this guy's hand, right? And I'm gonna model his hand to be what we call an airfoil. Okay, this is called an airfoil. This cross section is called an airfoil, and this is the same cross section that the airplane has, that the airplane wing has. So if you wanna go and look how the airplane wing looks like, it's gonna look something like this. So if you go deeper into the page, you're gonna have in here the plane. Okay, and then you're gonna have in here another wing. Okay, so what I'm saying is that the cross section of the wing, okay, it's called an airfoil. This is an airfoil. Okay, so I'm gonna model his hand to be the same way as the airplane wing is, because the same principle that applies in here applies on the airplane. This is the same principle that makes the airplane fly. Okay, so what's happening in here is that this is the free stream. This is the free stream velocity. Okay, this is the free stream velocity. Okay, which is we can say the relative velocity between the car and the headwind. Okay, so you have in here the velocity of attack. Okay, as you move forward, the wind in here is gonna attack the guy's hand, right? And what's gonna happen in here is that once it hits the guy's hand, okay, you're gonna have in here the streamline is gonna continue like this with high speed. Okay, so it's gonna continue like this with high speed. So these are the streamlines. Okay, and as you move away from the wing, you're gonna have the streamline back to normal, back to horizontal. Okay, and in here you're not gonna have that much of a speed because you don't have so much rotation. Okay, so in here you're gonna have a region with low velocity. Okay, at the bottom of the wing. So what I'm saying is, the first thing that I want you to understand is that because of this circulation here, because of this arc, because of the shape of the airfoil, what's gonna happen is that in here at the top of the airfoil you are going to have a region with high velocity. Okay, due to the arc in here. Okay, due to the arc. So because you have circulation, speed in here is gonna be high compared to this speed at the bottom of the wing. In here you have a region of low velocity because this is relatively straight. In here it's relatively straight, it doesn't have an arc. Okay, so this is the first thing I want you to understand, is that the top of the airfoil has a region with high velocity and the bottom of the airfoil has a region with low velocity. Now, what does this velocity gradient, this velocity difference, have to do anything with the lift force? And it all goes back to a very important principle that we discussed previously in the chapter, and it's called Bernoulli's principle, Bernoulli's equation. Bernoulli's equation is the equation behind the lift force that acts on an airplane. Now recall, if you remember Bernoulli, recall that Bernoulli's equation comes from the conservation of energy, and it's applied between 2 points along a streamline. And what this equation says is that the pressure head P1 over gamma plus the elevation head plus the velocity head, okay, between these 2 points are equal. So P1 over gamma plus Z1 plus V1 squared over 2G plus Z2 is equal to P2 over gamma plus Z2 plus V2 squared over 2G. Okay, now what I'm gonna do is I'm gonna apply Bernoulli's equation, or I'm gonna consider Bernoulli's equation at this point, which is 1, and at this point, which is 2. So I'm gonna take 2 points, right? One at the top of the wing and the other at the bottom of the wing, and you're gonna see what happens in here. So due to this difference, negligible difference in elevation, okay, because elevation is the vertical position above a certain datum, the difference in elevation between these 2 points 1 and 2 is negligible, can be neglected, right? So in here in Bernoulli's, I can simply cancel out Z1 and Z2 because the difference in elevation is negligible. So Bernoulli's equation, as a result, will reduce to P1 over gamma plus V1 squared over 2G is equal to P2 over gamma plus V2 squared over 2G. Looking at this equation, okay, we get to a very important conclusion, and that for energy to be conserved, okay, if you have high velocity, it's necessary that you have low pressure, okay, because as velocity increases, pressure decreases, and as velocity decreases, pressure increases. Why is that? Because to maintain to maintain energy conservation. Okay, so given that the elevation difference can be neglected, whenever the velocity increases, pressure decreases, and whenever the velocity decreases, pressure increases. So we can relate the high velocity zone and the low velocity zone. Instead of dealing with velocities, we can now deal with pressure. Okay, and this is what we're gonna do. So for example, in here at region 1, we said that we have a very high velocity zone, and therefore we are going to have a low pressure zone. And at region 2, in here, we have a low velocity zone, and therefore we are going to have a high pressure zone. So to make this clearer, if you go to the airfoil of an airplane, okay, that is moving with a certain speed, okay, what's going to happen in here is that at the bottom of the wing you are going to have a high pressure zone represented as plus, and at the top of the wing you are going to have a low pressure zone represented as minus. Now this difference in pressure will create a force, because we know from fluids that a force is created from a place that you have a high pressure to a place that you have a low pressure. Okay, because the wind likes to move, or the fluid likes to move from a place of higher pressure to a place of lower pressure, and therefore it will exert a force. Okay, and this is the force that goes from the bottom of the wing to the top of the wing, and it's called Fr. Okay, so this force is created because of the difference in pressure. The difference in pressure is due to the difference in velocity. The difference in velocity is due to the shape of the wing that will create a high velocity zone at the top and a low velocity zone at the bottom. Now this resultant force in here, as you can see, it has 2 components. It has a vertical component, which is exactly the lift force, and it has a horizontal component, which we call induced drag, and we're going to discuss this later in the videos. Okay, so it all goes back to Bernoulli's principle. Very important, man, very important equation that explains the idea of the lift force. Okay, engineers were able to use Bernoulli's principle in order to design this airfoil to create circulation, and circulation created a difference in velocity, and the difference in velocity created a difference in pressure, which resulted from a high pressure zone at the bottom of the wing to a low pressure zone at the top of the wing, which created this force whose vertical component is the lift force, and this is the force that will help airplane goes up. Now what does this force depend on? We're gonna see in the next video. I'm gonna give you the formula of the lift force, and we're gonna solve very important examples concerning airplanes. I hope you enjoyed this video, and I will see you soon in the next